So remember, we don't have class Tuesday. Advising day is on Tuesday, so we'll not have class. I'll be around all day, but we'll be in the class. You've got your homework assignment from last time I assigned, and let's do it next Thursday as well. Because I don't think it'll take you that long to do it. It's just we don't have class Tuesday for return it next Tuesday. So anyway, how'd the code go? Did it work? Hope so, because that's what we got to build off of, right?
It spits out values.
Does it match the values you have in Excel? No. Okay. It may get when it does work. I think you all went right after class and worked on this and got it to work, right? So let's happen. I'm glad it spits out values. You want to email it to me? I'll work off of yours since no one else is answering me. Might be broken. Okay. We want to make sure it works, like I said, and then no, I don't want to open up things from last one. So I haven't opened this up for a while. It's probably gonna make me log back in. What's that?
So doing a check to try and find it before I share it.
Make sure it doesn't want me to log back in to do the duo notification again. I haven't been on email here for a while. My deleted items is going up though. I never clean out my deleted items folder, so that's why it's over. It's just updating all the ones that I've deleted since I've opened this one on this computer. That's why it's going up. I have rules set that when students email me, I just automatically delete them. You're really funny though.
No, okay.
And then we just went back down again. That was kind of fun. Ah, cool. That's awesome. All right. So and you printed all the values out as well. Okay, cool. So let's see if we can. Did I save the Excel file? I'm not sure I saved my Excel file from before. Somebody have the cubic spline Excel file saved they can send to me real quick. I don't think I saved it from when we worked on it. And I'd rather not go hunt through my directories if somebody else can just email it to me real quick. I just want to use it so that we can compare the two. Because we know, at least hopefully, the spreadsheet works, right? So the goal here would be to get the code to match, but the values that are coming out. Everybody's gonna watch the recording back. There's been a lot of dead air today, apparently.
Underscore X got deleted.
What's that?
It said an underscore X got deleted. So it wasn't.
Oh. Well, that would do it.
Couldn't find a delta.
That does happen.
Let's try it.
Anyway, send me the Excel spreadsheet. Okay. Hopefully it's coming. Oh, there's my X's. Cool. All right. So this we already have the points, and we can already see what the values are. So let's just work off these points. Well, just as easy as anything, right? So, oh, that got really small. All right, so let's enter Austin's code here. Click the run button. Yeah. Okay. Assume we just need X's and Y's. Or yeah, the list. Okay. I wonder if that might be part of it. All right, so there's the X's, there's the Y's. All right, so let's see what's going on. All right, so it's getting some calculation issues, obviously, as it's getting to the end of a list somewhere. So we must have some index messed up at some point, because when it gets to a point where it can't reference where what an element is in the list, it'll just put a not available kind of thing in there. All right, so let's see what we've got. Let's just do this a little bit at a time here. Let's print without a capital P. Let's actually hit the right keys. Let's make sure our deltas are getting calculated right. Interesting. Oh, there's part of our problem. I'm going to end this for loop here. Which means there's probably an extra bracket in here somewhere. Here, maybe? Let's see what happens. Darn it, missed the button. All right, so part of it was your delta was in your loop. We want to calculate our deltas first before we go down here. So we'll make sure we end that for loop at that point. I think our deltas now are getting calculated correctly. Let's make double check. Make sure that's not the right window. What's this window? 2, 3, 5, 4 are the X's, and negative 2, 9, 10, and 16 are the Y's. Cool. Good. All right. So that's done. All right. Oops. That's not what I want to do. I want to delete it out of here. There we go. All right. So let's see what else we have here. So you've started off. Should have your first and let's see what's running now. This is what we ran, right? Yeah. Okay. So this first one is your C's here, right? We have how many points? We had 5 points to start with. So we should end up with 6 C's. Because remember we got that dummy one, right? 2, 3, 4, we got 7 here. All right, so we have 5 points. We should have 4 functions when we're done, right? And then the C's, the first C we know is 0, and then, well, actually, I guess we should have maybe it's 5 C's instead of 4. Well, it doesn't matter. We'll figure it out as we go along here. Are any of these C's right? I don't think they are they? we go back over here, no, okay. All right, so, because the first thing you printed was the C's, right? Okay. So let's see what we have here. Let's make sure we've got our formulas in here, right? So let's make sure we can go back through and match up all the indices. So we should have a 2 delta 1 plus a 2 delta 2 to start. And a delta 2 here, and then right below that should be a delta 2, a 2 delta 2 plus 2 delta 3 here. Right? So let's actually, why don't we do that to start here? Oh, that might be another problem. Let's cut it, because we should cut that off as well. And I think maybe this might be a couple of problems we have, as the for loops aren't cut off at the right spots. Let's try that first. I didn't put the braces in where we had them, but okay. Ooh, that's a little better. That's more better. I think I have the right number of things in there now. I don't. The numbers aren't quite right, but at least we've got the right number of things, right? Because we should. This last C doesn't matter. That's. What's that? Say it again.
Ants 1 and Ants 2 are shooting back the wrong thing.
Okay. All right. So at least we have the right number of things now. I think part of the problem was that the for loop's not cut off in the right spots. Okay. So that's good news. At least we're down to what we need, the total number of things we need. They're just not getting calculated correctly. You're getting into C's first, right? C's, B's, D's. All right. So let's see if we can figure out what's not getting, because at the very least, if we got through our, what's wrong? Sorry.
Oh, I had different Excel values.
Oh, you had different Excel values than wasn't here?
Y values. I had a different X and Y setup. I was just seeing which one.
Oh, I was using the one there.
Oh, I just typed in the one that Max had sent me just because I already had those values calculated. I just didn't want to have to redo it. I was just trying to go off the one we already had finished. All right. So we should, okay, so in these values here, should match up with if I go back over here, should match up with hopefully these values that are over here. So let me print off the answer 1 values here and see what we get. Because those should be the ones we're working off of, right? Those are the ones we calculated first and then reversed the process. So let's see what we've got. Okay. 10, 15, 16. Hey, look, those are right. That's good. That's good news. These were the ones that we're calculating from the answer 1 values, right? Those should match up with these values right here, which they do. All right. That was good, right? That's a good thing. What's that? What'd you say?
Found the random variable that's been throwing things off. There's an extra extra element in answer 2 that's popping out.
Ah. All right. So those are good. So why isn't? So okay. So these are good values, right? The 10, the 15, the 16.344 are matching what we got in our spreadsheet, right? So there must be something going on, because when we calculate this one right here, this should just be the constant divided by the 16.344, right? Because remember, if we go back over to the spreadsheet, I know you can't really, let me see if I can zoom it in a little bit. When you go back over the spreadsheet, remember that we take this value and divide it by that one, right? This one's correct, so this one must not be right. So let's see if we can verify that. One of the best things about programming, right, is debugging. No? Don't like to debug? Neither do I. Let's go back here. All right, let's see what we got. All right, so if I go back over here, the 12 is right, but I don't think the other two were. Negative 3.9 is not right. Okay, so what do we got here? Oh, I see it. I think I see it. So calculated your answer 1 here, right? And we're trying to keep track of the constants as well. But notice that when we got our new answer 1, we've appended it already. No, this should be this shouldn't matter because it's depending on the end. I was thinking that maybe this index wasn't right, but we're dividing by the wrong thing, but I don't think that's what's causing it. Do we have the right multiplier? Oh, no, it's not the right multiplier. Aha, now I see it. Remember the reason why we had delta x sub I plus 1 squared was because there was a delta x sub I plus 1 here, and then we were multiplying it by the multiplier, right? I don't want the squared here. I want this to go away. I don't want a squared in that spot. Remember, the multiplier is negative delta wherever over the previous answer. We were multiplying it by that one, which is why we used the squared. But that's not the multiplier. The multiplier is just the opposite of the delta over that previous answer one. Let's see if that works. No, not quite right yet. Better, different, but not quite right. Oh, okay. We need to multiply it by something. Okay, so remember that on this side is your 3 times delta 2 over delta 1 minus, or sorry, delta 2 over delta 2 minus delta 1 over delta 1, right? My multiplier for this row was what? The delta 2 over the 2 delta 1 plus 2 delta 2, right? But notice I got to take that and actually multiply it by something. We don't have that, right? We haven't multiplied it by anything. We just subtracted it off. So it should get multiplied by, let's take this, copy it, bring it down and paste it, and, oh wait, I don't need to do that. That's silly. I've lost where I've got parentheses. There we go. Okay, I need to multiply it by what the previous answer was. Oops. Because I need to work off of this one to get to the next one, and it's going to change. So it should be answer 2 of I that we need there. So let's see if that works. And I'll scroll back up to that in a second. Oops. Hey, I think we got it. There's the 8.185. Here are your C values. Go back to the spreadsheet. Those match, it looks like. Let me see if I can put this all on the screen at the same time. Now, all at the screen at the same time. There we go. Here are the C values. Not quite the C values. That C value is right. Those two aren't. Okay, but at least we got to this point. We're getting there. Let me go back. I'll go back to the code here in a second. We're getting close. We've got our values are correct in those different things here. Okay. So again, let me go back to the codes to tell you what we had to do. All right. So back over here, we've got to do our elimination step. So these are getting eliminated correctly now. These weren't because we weren't working off. We didn't take our multiplier and actually multiply it by that and add down. And then it changes this. That's what the next one should be, right? So that was why I needed to. Our multiplier is just that delta over the previous answer, whatever we've changed it to. And then divided by our times whatever that value is. Well, we need to work off this one to get that one. That changes. We work off that one to get the next one, right? And change it all the way down. Okay. So let me go back up here. The answer 2 is correct. Those values are matching now. So let's see. The first C value is correct. We've got that right. But what's going on here? So as we work back up, remember we have whatever this number was here, whatever our last C was, we're going to substitute it back up. So if this was your C min minus 1 times whatever that value was, this is going to equal, that was where we had whatever the last answer, whatever the last one was, right? We need to plug that in. Since we're appending it on the end now, we should always be working off that one. That gets multiplied by that. Okay, so the one right above it is what? So as we're going down, remember your last row. Was that, and then that, so this is the very, very last row. Try this again. This is, let's go right above it. So this one would be your delta n minus 3, 2 delta n minus 3 plus 2 delta n minus 2, delta n minus 2 there, right? Yeah. And we said, and then the very, very last row was that a 1 and a 0 on the other side. So we said that this got rid of this, and then this went away. We got rid of that row and that column, right? Just by eliminating up, and it didn't change anything else. We've gone all the way through the row reduction, the elimination process. This number here didn't change. That should be delta n minus 2. Let's make sure that we've got our indices right for the delta. Because my guess is that's where our issue is going to be. This is betting. So your deltas go from, so we want the n minus second delta. N is the number of points we have. We should have one. How many C's do we have at that point? I'm guessing where the error is going to be. My guess is the error is going to be in one of these two indices here, depending on what we need. So we just need to make sure to get the index to match up. So our C values have length 3 at this point. Is that right? Or sorry, not the C values, the answer values. All right, you have 3. Is that right? 1, 2, 3 of these. Okay. So we had 5 points, so that should be the third delta. I think we may need a plus.
Could you also change the range of I to the length? Or does that mess up the other ones?
Well, let's think about what we need. We can change it. It's just one. I don't want to mess up the other ones. We can change the whole thing. That's not a problem. But let's make sure that we've got everything correct here. So we have 5 points, so your n should be 5, right? Correct? Yeah. Because the n's corresponding to the number of points we have should correspond to the number of points we have. We want the third one. We should have, let's think about it. We should have 3 rows left, right? When we're done, when we do our things. So we should have 2 delta 1 plus 2 delta 2, a delta 2 here, and a delta 2, a 2 delta 2 plus 2 delta 3, and a delta 3 here. And then this one should be delta 3 and a 2 delta 3 plus 2 delta 4 is what should have been left when we do all of our elimination things. So this should be 3. But when I do the length of answer 1 to 2, length of answer 1 is 3, and I'm subtracting when I'm getting the second delta instead of the third delta. So what if we put in a plus 1 here to adjust where we are? See if that changes it correctly. That was it. Because that's -6 point. Let me put these both on the same screen at the same time here this time. Or don't do that. That's crazy. Why would you want to do that? Here are your C values. 1.3808575 matches. Minus 0.60292, that matches. And those match. Cool.
What was that last thing you changed?
The very, very last thing that we changed was this was referring to the wrong delta value in the list. We needed to add an extra plus 1 in there to get to the right delta value in the list. Awesome. Let's make sure the other values match now too. That's important, right? All right, so let me go down here, pump this up a little bit so I don't have that thing blocked on the screen. Why don't you just put it on the side like I want it to start with? Well, once our C values are right, these other ones should be just a matter of going through and getting them, and those are all correct as well. Cool. All right, so we've got, thank you for getting that done so we can work off of it. So, cool. Now we've got code that should be working correctly, hopefully. That was the whole goal of this exercise, was to get something that works correctly. Is your value weird?
Just my D value.
Yeah, okay. All right. So now that we've got this code working correctly, let's see if we can get a graph of this cubic spline going through these points. So the idea that we're going to use for this is, well, we can just plot the points. R will plot the points easily. You've got your list of X's and you've got your list of Y's, right? Well, or you're going to be passing the list of x's and the list of y's through, correct? That was how we started this, correct? So to get the plotting the points, that command is pretty straightforward. We can just use plot. You have x's and you have y's. So I can just do plot, and the way Austin typed it, he had the inputs of just x and y. So we can just do plot x comma y there at the end. Okay, just to show you what that looks like. Oh, yeah, because you're stupid and don't like to plot things when I have that window too small. There you go. There are the points. And you can change, there's different parameters that you can use to change what the points look like. You can change them to asterisks if you wanted to. You can fill the points in if you wanted to. It doesn't matter. But that's what the points look like. Okay, Lane.
My D values aren't right, and I don't know why, because I'm pretty sure my code for the D values is this.
Okay, let's see.
Clearly it's not, but I don't know where.
Your D values are not right?
Yeah. Like the last one, I'm pretty sure was accurate, but these three were not the same.
I see it. You're missing a parenthesis. You needed what your parentheses here on the end.
These
These
are
are
there.
yep, these
Okay.
are there. Yep, that's what caused it. That's what did it. All right. So again, that plot command there plots your points. So our goal, now that we've computed the B's, the C's, and the D's, is to play connect the dots. Right? Okay. So from your first x to your second x, we want to use the y value, the B, the C, and the D to get to that from there to there, and then connect from there to there, connect from there to there, connect from there to there, and see what we got. That's the whole point of this, right? All right. So remember that in this particular one, I want to switch. Let me switch back over to the Excel real quick. In this particular one, your first y value is -2. Your first b value is -1.92 and change. And your first x value, I think, was -1, right? Is that right? I'm just doing it from memory. And then your first c value is 0, so I don't have anything there. And then your first d value is the 0.230146, right? It should be an equal sign. That should be our first spline, and that should go from -1 to 1, right? The next one is the first one. The y value associated, that one was a -4. The b value is the 0.84. The x value is 1. Your c value is 1.38. And then I have an x minus 1 squared. And the last one was a 0.22. And I know I've got extra decimal points on there. Whoa. And then an x minus 1 cubed here. All right, and then so on down the line. I want to add each of these functions in on the graph. But I only want to plot from -1 to 1 for the first one, from 1 to whatever the next x value is, at a 3, whatever it was. I just want to go, every time I just want to plot just those pieces. And then I want to put them all on the same graph. I want to play connect the dots, right? That's the whole goal of this, right? I want to play connect the dots and see the nice smooth graph, right? So again, we're going to use R to help us. Well, if I want to graph each of those functions and change it each time, I probably want to use what? I need to go first set of values, second set of values, third set of values. Well, I probably want to use a loop, right? Okay. This one I'll just go from 1 to the number of points. I got done your X list. I want to do your, not the number of points. I want to do number of points minus 1, don't I? Because I have one fewer function than points. I could use the length of y minus 1. I could use length of b values. I could use length of d values. I could use length of c values minus 1. So I got one more c value in my list than the others. All right? I want to plot these as functions. And I want to add them to the current plot that we have. So remember, to plot a function, I need to declare a function and then use the curve command to plot. That's one way we can do that, right? So the first thing we need to do is I need a function. Oops, let's call it, doesn't matter, I'll call it G, just for, I could call it S since I'm using S for spline. Maybe I will call it S. Why not? All right. What do I want the function S to be? By the way, make sure you do it as a function of a different letter than we did the other ones, because we passed in an X and a Y. Right? I don't want to say function of X when I'm already doing, I mean, it should be okay, but let's just use it as a different letter. Okay. What do we want to return out of this? Yeah. Yeah, so I need to use a minus each time, because it'll do the minus a minus for the, yep. So remember, the form is I need the y value plus the b value times x minus the x value. In this case, I'm using the z because I have x doing a different letter, right? And then I would do the same thing for the c values. And you just square that one. And I need to do the same thing for the d values. And then cube that. So this is just, well, after we've computed everything, this is what the format of the function looks like, right? The first one is just your y plus your first b times x minus the first x plus c times first c times x minus the first x squared, and so on up the line, right? The for loop will change it each time. It will change the function. Does that make sense? That one's not too bad, right? It's just a matter of getting the function computed each time. Then remember, the command to plot this will be the curve command. So we'll have curve. So the curve here, I defined it as S, so I'll do the curve of S, right? Okay. Now that I have that curve, I want to make sure I only plot the curve for the x values that it's defined for. Well, the first function goes from first x to second x. The second function goes from second x to third x, right? So what do I want to set my x limits equal to? Good. Yep, x of I and x of I plus 1. Good. And then the last thing we need to make sure that we put in here is that I want to add it to the plot we've already created, right? We created a plot of points. I want to add these curves and play connect the dots. So the last thing that I want to make sure I put in here is that the add equals t. think it's just a T. We'll find out in a minute. Yeah? Okay. So again, if I can get this off of here. This for loop is just going to calculate the number of splines that we have and plot them. All right, so we've got a function for each one, and it'll plot each of them. And then, like I said, connect the dots. So let's re-enter this code. Run. And then let me move this over and recompute. Whoa. Why did that do that?
Somewhere you wrote, like in the S function, you wrote d values and then you didn't put the brackets.
Oh, thank you. That would do it. Thank you. Good eye. That was kind of cool looking, though. I like that graph better. There we go. It's kind of cool looking. And we can see that our spline really is going through each individual point. And it is nice and smooth, right? We don't have any weird corners in it. Okay. So now, like I said, we all are starting in the same place. So this is what we're going to start to modify off of to do your major assignment. What questions do we have about this? I can also make sure that I send this code out so that everybody has it. We also, like I said, we all want to start in the same place. We want to start with something that works, right? That we know works for this. Okay? All right. Pardon me. We're not going to do this particular thing, but some modification that you might think about wanting to do to this kind of program. Pardon me. The whole point of doing this, of course, is to try to interpolate these points with a function. We've done polynomial interpolation before, right? One thing that you might want to think about doing a modification, this gets a nice plot, but if you're doing if you're doing an interpolating function to go through these points, you might want to use it to estimate what's going on in between. So you might want to, a modification of the code might be, okay, if a user inputs a value, you spit out the appropriate place where it's supposed to be. Spit out the appropriate Y value that goes along with it. So if you wanted an extra credit opportunity, that would be something that you could do and modify this particular code rather than, well, you could plot it too, but have it take an X value, whatever the X value is that the user's putting in there, and it'll spit out the right Y value in that interval, in the appropriate interval. Okay. So that would be a good extra credit opportunity as well. And I don't think that would be a hard modification to do. All right. Anyway, like I said, we're not going to do that for our purposes because I want you to do something else, but that is a modification that could be like I said, an extra credit opportunity. All right. What I want to show you next is how we're going to, well, a couple of the skills that you'll need to be able to do your major assignment that I want you to do. All right. So one of those is, pardon me, to be able to read in a set of points from, pardon me, from an Excel file, actually a CSV file, comma separated values file. That's what the CSV stands for. And from the way we're going to create that particular file is by plotting some points. All right, so here's what I mean by that. So I'm going to go over here and I'm going to introduce you to a new program. It's GeoGebra. GeoGebra is actually a really, really nice program. those graphing capabilities. It has a computer algebra system in it. It has an integrated spreadsheet in it. And you can do all of it online. You can also download it for your computer, but the stuff that we can do is all online. And literally the only thing we're going to do is use the being able to plot points in a graphics window, and then you grab the different coordinates off the points in a spreadsheet, and we'll copy it over to Excel instead. So the website you'll want to go to is geogebra.org, and then it's /classic. We want to use the classic menu because, the classic calculator, because the classic calculator has the integrated spreadsheet. And they've updated their website, and just going to geogebra.org, I couldn't actually find the classic version on there through their menus. So if you go to, I'll write it down here so you can see it, geogebra.org/classic. I also have this printed on your major assignment sheet that I'm going to give you here in a little bit. Okay, so notice that on here, like I said, there's lots of different things that you can do. You can graph functions, you can define functions, it has an algebra window, it has a computer algebra system window. That means it'll do things symbolically. So if you needed a symbolic derivative or a symbolic integral, for example, it'll do those things symbolically. You can type in a function, say, integrate with respect to x, it'll spit out the integral with x's in it. Okay. It's a really, really nice free program. Free online available programs. Fantastic. Part of the problem is the last time I taught this class, I tried to do a lot of the stuff in GeoGebra, and since it's all online, the back end things don't do a lot of the heavy computations quickly, and things will get bogged down, and things are locked up, and it's just a pain. So that's why I haven't done much with it. But there is this one thing that I want to do in order, and I'm going to show you what you need to do here in a minute as well. But just going to show you the skill that we're going to do right now to get some points, pick out the individual pieces, and get them copied over to Excel. All right. So the first thing I'm going to do before I do anything else is I'm going to click on the spreadsheet option here so that it also pops up. Oops. Yeah, that's okay. That's fine. I don't need to see the... I guess I do need to see the algebra part. I don't know why I just did that. On view, if you go over to the... I like how people call this the hamburger menu. Always cracks me up. Go over to the little hamburger menu, click on algebra. I'm going to want that window too. I need that window open for when I type. I need it for one specific purpose. Okay. All right. So here's what I want you to do. Click on the graphics window, the one that has the axes on there. The axes aren't important. Over here on the left-hand side, there's what looks like a little point, right? So one of the things that GeoGebra will do is geometric constructions. If you did constructions in geometry in high school, it does all those classical constructions that you can do with a compass and straight edge. If you didn't do that in high school, you can ignore what I just said because we're not going to do any of that. Take geometry in the fall. I'm sure Dr. Olson will talk about that. I literally just want to use the point command. All I'm going to do is I want to just click over on the graphics window and just make some points. That's all I want to do. Okay. So here's the idea. I'm gonna click from left to right, just so that I'm making some points here. Doesn't matter where you click. I'm just gonna make a few of them. Okay. And here in a little bit, I'll show you more precisely what I want you to do. So I just made a list of 5. You can make more, you can make fewer, but there's 5 points. Okay. What I want to do is I want to grab the coordinates of those points. I want x coordinates and y coordinates. Basically what I want to do is I want to import this information over into R and then create the cubic spline there. That's what I'm doing. Okay. All right. So it's a little clunky, but it's not too bad. The very, very first thing that I'm going to do is I'm going to create a list of those points. And it sounds harder than it is. use braces, and then just type in the letters for the points separated by commas, making sure you capitalize them. The capitalization is important. So A, comma B, comma C, comma D, comma E. I made a list of points. Notice that when I hit enter, it actually popped it to the top because what it orders, it collects things of like type and then just puts them in different spots on the screen. So it stuck it at the top, but it also gave it a name. The name of that list is, that's an L. It's a small letter, L1. We can now refer to that list by that letter. Okay? So again, what I want to do is I want to pick off the X coordinates and pick off the Y coordinates so that I can import them over to R and let R do the calculations for the splines. Okay? All right. Here's how we do that. Here's how we do that. The first thing I'm going to do is I'm going to type in the number 1 up in the upper left-hand corner. And then below that, I'm going to just say A1 plus 1. So you can refer to other cells in the spreadsheet by their cell names just like you do in Excel. Okay. Unfortunately, unlike Excel, if you want to put the 1 and 2 right on top of each other and then copy down, Excel would recognize the pattern and make it 3, 4, 5, 6, 7, and so on down the line. GeoGebra doesn't do that. That's why I have to put this, do 1 plus the previous one and then copy down. Okay. Now, I'm going to copy down to 5 because there's 5 elements in my list. If my list were longer, I would pull it down as far as I needed. Okay. I'm only doing this because I want to use these to reference the index in my list. Because I need to pull off the first X coordinate, I need to pull off the second X coordinate, and so on down the line, right? Okay. So I'm going to actually do this in stages. You can probably be clever and do this in extra steps. There's a command in GeoGebra that will allow you to pull off each element in a list. Shockingly enough, the name of that command is element. So I did equals. You start off a function in GeoGebra, just like you start off a function in Excel. You start with the equal sign. Capitalization matters, so make sure you put the capital E. The function names in GeoGebra all start with a capital letter. So make sure that you put the capital in. I need to tell it what the list is. I already told you that it named the list L1. If you wanted to call it a different name, we could have started off by giving a variable name to the list and then said equal that list of things we created. I didn't bother because it's always going to be L1. Okay? We're always just going to create one list of points. And then I put a comma, and then I say the index that I want to pull off. Well, the index that I want to pull off is over in column A, so I'm just going to make that A1, and it should, if I spread that out a little bit, pull off the first point. Okay? So again, if I go in here, there's your syntax. Again, it's equals element is the command. Again, capitalization is important. Make sure you have a capital E. And again, I don't want a capital L1 because I need to refer to the list element, list 1. Okay, so little L1, and then the A doesn't matter if it's capitalized or not, it's going to recognize the cell. All right. I'll pull this down, and it grabs all 5 points. This is kind of fun. Okay. All right. These are the points, right? I want the X coordinates and I want the Y coordinates separated because that's what I need to pull into R, right? Okay. So the way to do that is really, really straightforward. If I want the X coordinate of something, there is an X of command, and it'll tell me what the X coordinate is for that point. So in column C1, I want to type X of A1, and that'll pull off the X coordinate of the first point. Well, should have. Why didn't you do it? I want B1. Sorry, I did put A1. There we go. That was why I didn't like it. Sorry, the point was in B1, not A1. My apologies. Should be x of B1. And then that should pull off the negative 5.45. Over in column D, I'll do y of B1. Just the same exact command, just change the x to a y. I hit enter. I get the x and the y coordinate, and then just like in Excel, I can go up here and grab the little square. Well, if I actually grab the square, I can highlight and grab the little square. This is another reason why I don't use GeoGebra very often, because there's some pieces of it are clunky. And there are the points. If you want more detail with more decimal places, you can set those in GeoGebra, but we're not going to worry about how precise the points are, because we're just going to use this to help us recreate something. That's the whole goal here. So far, so good. We're able to get the list of points. Cool. All right. Now, I could retype all of these, but that seems, I don't want to retype all of these, because especially when you're going on later on, you're going to have a whole bunch of points. So I certainly don't want to have to retype everything. All right. I'm going to highlight and copy this. I'm going to go over to Excel, and I'm going to paste it. So whatever the list of points I just created, I'm going to highlight it, copy, paste over to Excel. The reason why I'm doing this intermediate step, GeoGebra won't save things in different formats besides a GeoGebra file if you want to use them later. And R won't read a GeoGebra file. So I'm doing this intermediate step so that I can be able to access these points in R. Okay. The numbers aren't important, which is why I haven't zoomed in on this. I'm just literally just making a file here. Okay. Here's how I'm going to save this as that comma separated values file, the CSV file. So I'll go to File, Save As. It is important that you put this, well, when you're going to read the files, it's important you put this in the directory that R thinks you're putting it in. Okay. But let me show you I'm going to come back to this here in a second. But let me show you what type of file you want to save it as. Whatever name you give it, I don't care what name you give it. But under it, where it says Excel Workbook and saves it as an Excel file, which, by the way, you can have R read in Excel files. I just think it's easier to work with the comma-separated files. There are two different options. There's a CSV UTF-8, and then there's just a CSV. Use the CSV. Do not use the CSV UTF-8. For some strange reason, there is an extra little character that gets saved in this file that'll throw things off. Okay. I don't know what it is, but it's happened in Python too. There's some little thing that happens if you save it as this type of file than this one. I don't know what it is. I haven't been able to figure it out. And trust me, I've tried to figure it out because I've got another program that I run to send emails to prospective students, and it was throwing things off because of one little character. It was super weird. Anyway, you don't care about that. Make sure you use this particular thing. Okay? Don't use this one. All right. When I say, I'm going to come back to this. When I save it, I want to make sure I want to save it where R thinks it wants to work from, because I want to save the file and then pull the data in from R. Okay? Okay. All right. So when you pull the data in from R, there's a command in R that you can type in that's called get working directory. So it's GETWD and then open and close parentheses. This tells you where it thinks it wants to pull files from. Okay. If you're unsure where you're going to want to save it and where R is going to go look for it, you can use that command. Okay. You can also set the working directory if you want to change it. The command is SETWD. And then in the parentheses, you would type the path where you want to change it to. If you're not interested in changing the path, you can just figure out where R is working from and then just go save everything in there. Okay. So this is where R thinks that I am going to save, or sorry, it's going to go look for data in this particular folder or this particular directory. Folder, whatever, doesn't matter. I learned it as directory. Learning computer science stuff. All right, so let me go back over and save that file. I'm going to save this. I want to make sure that I am in my, it thinks I want to be in where? It said C, and it was under users, right? And me, make sure I'm going in the right spot. OneDrive, documents. Okay. And then I'm just going to call it data just because that's what I'm going to name it. But that was where, the reason why I'm saving it to is because that's where R said it was going to look for the file. Rather than me change the directory, I'm just going to go save it there. Okay. I know it's not, and it will tell you that if you save something as a CSV file, there are some formatting things that it can't save, which I don't want. All right. So go back over to R now. I can now pull this data in, and let me show you what the commands look like. I already have this typed up, so I can show you what it looks like. Maybe I can get through my files. I think it's here. All right. So these are two functions that I wrote that will get the data. All right. So let me just show you. The command for reading a CSV file is just literally read.csv. I will send this to you. You don't have to retype the whole thing. Okay. I just want to tell you what, so you don't have to retype the whole thing, all right? But I just want to tell you what the different things are doing here. The command for reading a CSV file is read.csv, okay? And then whatever the file name is, make sure you put the file name in quotes, okay? You do that. And then also it's going to wonder, it's the default is there are headers in the file, because it'll keep track of it. Because R is a data analysis thing. So it assumes there's going to be headers for what your data is, and we don't have any headers. So that's why I changed the header equal to false. And then all I did here was this syntax is going to, this length is just telling me how long my data list is. I want to pull off the first element, and then I want to pull off the second element. That's all that's doing. Okay. All right. Like I said, I will send this file to you, so you don't have to worry about getting it. But here's the idea. Let me run this. All right, so the syntax that I have this as, I want to make sure I save my x's as something, all right? The file that I called this was data.csv. Put it in quotes. It wants it in quotes, okay? But now I should be able to see that I got the x values that I put in that file. So again, the steps, making sure that after you save your file, you know where that R knows where you saved it. Okay? And then this is when I send you this, this is what the syntax is. Not a big deal. Same syntax for the Y's. Same exact syntax for the Y's. I just went back and grabbed the previous command I typed in and then just changed the letters. Okay. And now, if you do your cubic spline that we just created, it should come up with the cubic spline through those points. Now, when we did the plot, it made sure that it plotted and made sure it fit the points. And my cubic spline, of course, is going off the screen here. That's okay. But that's how you can read the points in. Does that make sense? All right, so now to tell you about what I expect you to do for your major assignment. So we've done this as given an X, get out a Y, and play connect the dots, right? You're going to modify this to, given a point, you're going to do parametric equations. And what you're going to do is recreate your signature using cubic splines. Okay? So let me show you how the process is going to work, because I already have code written myself for mine. Okay? All right. So I sent you the other day a parametric plotter, right? Where you could have a set of parametric equations and it'll plot it. Okay. All right. So here's what the process that I expect you to be able to do for this. So let me go back over to GeoGebra. I'm going to close this out and put a new one in here. I just want to start fresh. Okay. All right. So here's what I'm going to do. Over here somewhere, I have saved. Where'd it go? There it is. Can't see it because it's really super small. I saved the first letter of my name, my signature. Okay? All right. I want to show you what the process that you need to do to be able to recreate your signature. That's our whole goal here. All right. So the first thing I'm going to do is I'm just going to, since I've already got this scanned, I should be able to snip it. Just because I just want this little piece. All right. So if I snip. All right. So I should be able to copy this. Over in GeoGebra, if you have a picture and you're in the graphics window, so I'm clicking on the graphic window here, I can paste my picture in. Okay, so whatever picture you have, if you've copied the picture, you click on the graphics window, you can paste the picture in there. Okay. Now, if you grab these points that are at the bottom, notice it stores an A and a B where it is. I can pull this wherever I want, move it wherever I want to. The coordinates don't matter, but if you want to make sure you have more detail, you can expand your picture out. You can grab the A or grab the B. It'll also rotate it, which is kind of fun. You can make it bigger. So if you want more detail for where you can put your points on your signature, you can expand the picture out just by grabbing one of the points. Okay? All right. So now I'm going to do exactly what I did before. I'm going to plot points around. But I want to do them in order because I'll tell you in a minute how we're going to do this with the parametric. But I want to do this in order of how I would sign my name. Okay, so I'll just do it for this particular letter. So I'll just click on these points around. You may have to do it a couple of times, making sure that you get more detail that you want, making sure it's turning in the right spots, those kind of things. Okay. So notice here I've created several points, right? Same process that we did a few minutes ago. I'll make a list of these points. Notice it names them as you go around. The A and the B are already there, right? Because it put an A and a B at the corner, so it'll always start with C as you start clicking. Okay. So I'll make a list for C, D, E, F, G, H, I, J, K, L, M, N. That's where it stopped. Just as another, if you have more points as you're getting more letters, it will skip X and Y because those are stored for, X and Y coordinates. Okay. And then once you get past Z, it'll start doing A sub 1, B sub 1. If you need a subscript, just literally hit the underscore. It'll put it as a subscript. All right. Now I made my list. Now I'm going to grab those points just like I did before. So pull that down. Actually, I probably could have just saved the same spreadsheet I have. Oops. Oh, I don't want. That's right. And then pull. There were the points. Notice that I only clicked on 12 points, but I pulled all the way down. So I know I don't need these because those are just ones that weren't in my list, right? That's why it says question marks. Here I'll pull off x of b1. Here I'll pull off y of b1. And I'll just drag down to where I need them. Just like we did in the previous thing, right? It's literally the same process. Okay. Copy. I'm just going to paste over the top of this because I don't care about that particular file. It's already as a CSV, so if I just hit save, I don't have to go back and tell it to do a CSV again. Okay. So that's the process to get the points. Now what you should get at the end, like I said, after you modify your code, and I already have my code modified. Should say cubic spline 2. I already have my code modified. So the way to do this, since I said go around and order how you assign your points, make your, so your x is going to be a function of t. You're going to create a cubic spline for x in terms of t, using the t's as the x's and the x's as the y's, and do the same thing for the t's and the y's. Just for your t values, use 1, 2, 3, 4, 5, up until the number of points that you have. Those will be your inputs for each of them, okay? When you're done, you're going to want to plot x's and y's for each of them like we did for parametric. So that's going to be the tricky part, okay? But this, if I get my x's and get my y's, and then do cubic splines 2, I should recreate my letter. So at the end, I mean, this is the scale is kind of wonky because of the way the screen is, but that recreated the letter for me in parametric. Okay. So again, the process is going to be get your points, and then you need to create a cubic spline for the x coordinates in terms of the t value, create a cubic spline for the y coordinates in terms of the t value, and then parametric plot those particular functions as you go along. So that's the part that you need to modify. I'll get the code sent out so that they all start from the same place in the cubic spline code that we have. Okay, so you can modify from that. I'll also send out the code so you can read the points in from the CSV file. Yes?
Should it be our full first and last name?
You can just do your first name. It's fine. Yeah. Because if you do the other ones, then you're going to have to get spaces in there and create things. So just your first name is fine. Hey. Have a good one.